Hello viewers, in today's class we are going to discuss yet another important definite integral, right? So here we have to evaluate this definite integral, and here we see that the limits of integration are from 2 to 4 x over x square minus 4x plus 8 dx, right? So let us first call this integral as I, right? Now viewers, here what we will do, we'll make use of some standard results from indefinite integral, and then we'll solve this definite integral, right? So let us start. Now let us first see that in the denominator we have a quadratic function, right? So here in the denominator we have x square minus 4x plus 8, which is a quadratic polynomial, right? So this is a quadratic polynomial, and let us first make a complete square, right? So here what we will do, we'll try to form a complete square here. So we'll take these two terms, that is x square minus 4x plus 8, right? And now we can write here x square minus 4x plus 4, and here we have plus 8. So we'll add 4 and subtract 4, right? So we will write 4 minus 4 plus 8, because now this term, it becomes x minus 2 whole square, right? And this becomes 8 minus 4 is 4, right? So we have expressed this quadratic polynomial in terms of x minus 2 square plus 4, right? So once we have written this quadratic polynomial in this form, we can write here I is equal to 2 to 4, and we have x dx, and in the denominator we have x minus 2 square plus 4, right? Okay, now we'll take the help of the method of substitution, right? So here we'll put t is equal to x minus 2, right? So this x minus 2 will be taken as t, and therefore dt over dx is equal to 1, and we have dt is equal to dx, right? Since we are changing the variable from x to t, so let us change the limits accordingly. So here x varies from 2 to 4. So when x is 2, then the value of t is 2 minus 2, that is 0, and when x is 4, then t is 4 minus 2, that is 2, right? So when x varies from 2 to 4, t varies from 0 to 2. So now we have I is equal to 0 to 2, and for x we can write from here x is t plus 2, right? So we have t plus 2 here, and for dx we have dt, and for x minus 2 we have t, so this is t square, and here we have 4, right? Now what we will do here, we'll write I as 0 to 2, and we'll break this integral as a sum of two integrals, right? From here, so we have t over t square plus 4 dt, and the second integral is 0 to 2, and we have 2 dt over t square plus 4, right? Okay, so now we have these two integrals. Now here what we will do, we'll multiply this t with 2 and divide by 2, right? So we have 0 to 2, and here we'll write 2t, and then we can write here t square plus 4 dt, and here we can write half, so that 2 and 2 get cancelled, right? So here we have a special purpose to multiply this t with 2 and divide it by 2, right? And here we can take 2 outside, so we have 0 to 2 dt over t square plus 2 square, right? So now we can easily evaluate these two integrals, right? Now we see that in this integral, the derivative of t square plus 4 is present in the numerator, right? Because the derivative of t square plus 4 is equal to 2t, right? And we know from indefinite integrals that the integral of f prime of t over f of t dt is equal to a log of f of t, because whenever we have an integrand in this form, that is the denominator, in the denominator we have a function and in the numerator we have the derivative of that function, then we can directly write the integral as log of this function, right? So here f of t is t square plus 4 and f prime of t, that is the derivative of t square plus 4, is 2t, right? So this integral is of this form. So now we can write I is equal to half, and we have log of t square plus 4, and the limits are from 0 to 2, right? And now we have to take care of this integral. So this integral is again of the form that is dx over x square plus a square, right? And we know that the integral of 1 over x square plus a square is 1 over a tan inverse of x over a, right? So here the value of a is 2. So now we have 2 times of 1 over 2, then we have tan inverse, and we have t over 2, and the limits of integration are from 0 to 2. So now here this 2 and this 2 get cancelled, and now we can simply substitute here the limits, and we'll take the difference. So the first one is t is equal to 2, so 2 square is 4, 4 plus 4 8, minus we have log of c, here we have 0, t is equal to 0, so 0 square plus 4 is 4, right? And here we have tan inverse of c, when we take t is equal to 2, this is 2 over 2, that is 1, minus tan inverse of here we have t 0, so 0 over 2 is 0, right? And we know that tan inverse of 1 is pi over 4, right? So now I can be written as, here we have half, and log 8 minus log 4 can be written as the log of 8 over 4, right? Because the log of m minus log of n is equal to log of m over n. And here we have plus tan inverse 1 is pi by 4, and tan inverse of 0 is 0, right? So now I is equal to half, and here we have 4 2s are 8, so we have half of log 2, and here we have pi over 4, right? So viewers, the value of this integral is half log 2 plus pi over 4, which can also be written as log of square root of 2 plus pi over 4, right? Because here we have used that n log m is equal to log of m raised to n, right? So the value of this integral is log of square root of 2 plus pi over 4. So this is how we solve this integral.